Greetings to you everyone, right here watching this content. You're welcome to this Academy of Mathematics. You are welcome to today's video lesson. My name is Courage, and today I'll be teaching you on the laws of indices. Anyway, if this is your first time of joining us, hit on the subscribe button right now and please turn on notifications so you get updated and get notified whenever I upload good content like this. Like I said, we're going to be talking about the laws of indices. We're going to talk about exponential equations. So these are what we are going to learn in this particular video lesson. So all I want you to do for me is to focus your mind, your attention on the board with me so that you can learn everything I'm going to teach you today. So let's get started. Now, what do we mean when we say indices? What does indices mean? It is actually the plural word of index. So the plural of the word index is indices. The question again, what is index? Index simply means I can say power or exponent. Yeah, I can say power or what? Exponent. For example, I have 2 raised to the power 4. 2 here is the base, and 4 here is either the power, the exponent, or the index. So this is what indices is. So we are going to consider 7 laws of indices under this discussion. So let's get started and let's focus our mind. Let's start it. Law 1. Okay, so now let's do the first law of indices. The first law. The first law says that if a to the power of x multiplies a to the power of y, for example, the solution is equal to a to the power of x plus what? Y. Now, what are we saying? I have a first term here and I have another term here. Both of them have the same base, a. So what the law of indices says that pick one base and add the powers. That's a to the power of x plus y. This is what the first law states. Okay, yeah, this is the first law of indices. So we are going to solve these questions actually to buttress the point so that we know what the law talks about more. So the first question it says 5 to the power of 4 times 5 to the power of 7. We are asked to simplify this. We are asked to simplify 5 raised to the power of 4 times 5 raised to the power of 7. So how do I do this? 5 raised to the power of 4 times 5 to the power of 7 is simply equal to, what do you observe? The base are the same, 5, 5. So I'll pick 1. Then the powers are 4 and 7. So I'll add 4 plus 7. So this actually gives us 5 to the power of 4 plus 7 is 11. So this is the answer. I can also decide to simplify this by looking for the product of 5 times 5 times 5 into 11 places. The answer is still correct. But if I decide to leave it in index form, I think it's better that way. Question 2. 3 to the power of 5 times 3 to the power of 4 times 3 to the power of 4. I'm asked to simplify this. It's still the same. They have the same base, 3. So pick one base. By the time I add the powers, I have 9. So this is 3 raised to the power of 4, 9. And the third question, d squared times d to the power of 6. So this gives us d squared times d to the power of 6 is equal to d, 2 plus 6 is 8, d raised to the power of 8. So this is the first law of indices. It's actually very, very simple to understand and to comprehend. So we are going to the second law straight ahead. So now guys, the second law. What does the second law of indices state? It says, if I have a to the power of x, for example, divided by a to the power of y. Now take note, the first law, there was times here. That is the 2 times here multiplying each other. But in this case, I have division here. The first term divided by the second term. So the law of indices states that inasmuch as the bases are the same, pick one base, then subtract the powers. So a to the power of x divided by a to the power of y is equal to a to the power of x minus y. This is also equal to a to the power of x over a to the power of 5. So anyhow the question comes, in as much as they have the same base and the first term is dividing the second one, what do? Pick one of the base and subtract the second power from the first. That's what the law states. So let's attack some questions that we have on the board to buttress our point. Question 1 says, simplify k to the power of 8 divided by k to the power of 3. Okay. K to the power of 8 divided by k to the power of 3. What would this be? What do you observe? The bases are the same. K. So I will pick one, subtract the second power from the first. 8 minus 3. So I have what? K to the power of 5. That's the answer to the first question. Question 2. 10 to the power of 3 divided by what? 10 to the power of q. So it's simple. They have the same base also. I'll take one, subtract the second power from the first. So that's 3 minus q. So this is the answer. I can't simplify it more than this because q is not defined. It's just it's a letter. It's not a number, so I can't simplify it more than this. Then question 3. Okay, we are asked to write these two questions, questions as a single power of 2. That is the base. We are going to express this base to 2. Now, this is 2 to the power of m divided by 2 to the power of negative m. So I'm asked to simplify this entire term to a single power of 2. Now this is how I'm going to do it. 2 to the power of m over 2 to the power of minus m is equal to, what do you observe? They are dividing, this first term is dividing the second one, and also they have the same base, 2 and 2. So based on this law, pick one base, subtract the second one from the first. That's this one m minus this power is negative minus m. So this is now equal to what? 2 to the power of m. Negative distribute here, I have positive m. So this is 2 to the power of 2m. So this is what I've got. Now, the next question, which is the fourth question, is we're asked to express this as a single power of 2. 4 to the power of x, 4 to the power of x, divided by 2 to the power of 1 minus x. So what would this be? 4 to the power of x can be simplified to 2 to the power of 2x. 4 is the same thing as 2 to the power of 2 is equal to 4. So I will express this as this all over 2 to the power of 1 minus x. So what will I do? Based on this law, I have 2 to the power of 2x. They have the same base, so I put one base. Minus 1 minus x. So I have what? 2x. The negative sign here will distribute over. I have minus times 1, minus 1. Minus times minus x, I have plus what? X. Finally, I have 2 to the power of 2x plus x is 3x minus 1. So this is it for the second law of indices. It's very simple to understand. It's very easy to comprehend. So we are moving straight ahead to the third law. Okay, so let's talk about the third law of indices. The third law. Now this is it. If I have a term, I have a multiplied b all raised to the power of x, for example. The law of indices states that this same expression is equal to a to the power of x times b to the power of x. That is, the power here will be multiplied by the one outside, same also with the one of the second term, multiply the power that is outside. So a, b, all to the power of x is equal to a to the power of x multiply b to the power of x. This is what the law of indices says. So let's answer these 5 questions on the board to buttress this rule. The first question says, okay, we are asked to actually write all these terms without brackets. They are with bracket. So the question wants us to write them without bracket. And also they all have powers. So let's see how we're going to manipulate this such that there will be no more brackets in each of them. Question 1. 2a all raised to the power of what? 2. I'm also going to write this without bracket. Based on what I said just now concerning the third rule, this is equal to 2 squared. That's the power here is 1. We multiply this 2. That's 2. Then a here, the power is 1. Multiply 2. I have 2. So this is already without bracket. That's the solution. I've succeeded in writing it without bracket. Okay, now that's for question 1. The next question says we should write ab to the power of 4. ab to the power of 4 without bracket. It's also simple. So this will be what? A to the power of 4, b to the power of 4. It's as simple as this. The power here is 1, the power here is 1. Each of them multiply this general index to give me the resulting expression. So the third one, without brackets, m over n all cubed will be equal to what? It's the same thing. M here will multiply, the power here of m will multiply this general index to give me m cubed. And the power of n here will multiply the general index to give me what? M cubed. So I've written it without bracket. It is m cubed over n cubed. Question 4. That's minus 5 a to the power of 6 b cubed all squared. Okay. Divided by what? 5b to the power of 8. So let's see how we are going to handle this question actually. Let's see how we're going to handle it. So each of these terms that are here, each of them individually will be affected by this power. So listen. Minus 5, first of all, will have its own square. Then a to the power of 6. This is a to the power of 6. Multiply this 2. Then I have b to the power of 3. We also multiply the 2 times 2. Now, this 5b raised to the power of 8 is not affected by the square. So it stands alone. 5b to the power of 8. So this will give us minus 5 squared is 25. Then a to the power of 6 times 2 is 12. 3 times 2 is 6. So I have b to the power of 6. All over what? 5b to the power of 8. So what do you observe? We can actually apply the second law of indices, division, to simplify this expression further. 25 divided by 5 is 5. Now, there is no term in a in this denominator. So my a to the power of 12 will still remain. Now, I have a term down, b to the power of 8 and b to the power of 6. b to the power of 6 minus 8. We did it in the second law. That's the two of them have the same base. So you subtract the second power from the first. I have this. So this is equal to 5a to the power of 12. Then b to the power of 6 minus 8 is what? Minus 2. I can either leave it like this or I can simplify it to an expression that does not have negative index. And we are going to see that later, that this same expression is equal to 5a to the power of 12 over b squared. Don't worry yourself about that for now because I haven't shown you the rule. But stick to this first of all. But by the time we get to the rule, you're going to understand the reason why this expression turned to this. So let's finish our question. Question 5. Minus 2a squared to the power of 3. Okay? We have to write that without bracket. Minus 2a squared all over b squared all raised to power 3. The same thing we did here, we are doing it here also. So the general power here, which is 3, will affect each of the individual terms in both numerator and denominator. So this is it. Minus 2, we have the power of 3, that's this one. Then a squared, we also multiply this 3. All over b squared times the 3. So this is what I have. Minus 2 cubed is minus 2 times minus 2 times minus 2. That's minus 8. A, 2 times 3 is 6, so I have a to the power of 6 all over b, then 2 times 3 is 6, so b to the power of 6. So this is it for this fifth question. So I have written this answer is the solution to this question, writing it without bracket. Now, I want you to know that whatever laws that I'm going to tell you today, whatever proofs, they all work forward and backward. So I can actually write this answer, this expression back to this form. They work forward and backward. The rules work forward and backward. So anyhow the question comes, you know how to tackle it because you have the knowledge of the law. So we are going straight to the fourth law now of indices. The fourth law. What does this law state? It is almost the same as the third law we just considered. It says, if I have a, for example, to the power of x, and everything is now raised to another power of y, the answer is equal to a to the power of this x multiplies y, I have x, y. Now this rule works forward and what? Backward. I told you, indices laws work forward and they work backward. So, if I have something like this, this is simply the result. So let's simplify these questions to know this rule more. But if you follow me very well when I was teaching the third law, you can actually solve almost all the questions that are here. You can solve all, yeah, but I just brought the law. In case you see it somewhere else when you are studying indices, when you are studying mathematics, you know that you've learned it somewhere before. So watch this video till the end. It's very, very important. Question 1. X squared raised to the power of 5. We have to simplify all of this. X squared raised to the power of 5. So like what I said just now, this is actually equal to x to the power of 10. You know it. 2 times 5 is 10. So I have this. Question 2. C raised to the power of 4, all raised to the power of n. And this is equal to c. 4 times n is 4n. So c raised to the power of 4n. Question 3. xy over 2 all to the power of 3. Now, each of these terms will be affected by this power 3. So I have x, the power of here is 1, the power here is 1, the power of 2 here is also 1. So 1 times 3 is 3, x cubed. 1 times 3 is 3, y cubed. And 2 over 1 times 3 is also what? 3. So this is x cubed, y cubed over what? 2 to the power of 3 is 8. So this is a solution to this problem. Question 4 actually, okay, it's a little bit more difficult than this. So let's come here. Minus 2x to the power of 7, then y to the power of 4, all to the power of 3, divided by 4x cubed, y to the power of 15. Y to the power of 15. Good. So now let's attack this question the way it is. Based on what I did in the third law, this minus 2 will be affected by these 3. So this is simply minus 2 cubed, then x to the power of 7 times 3 is 21, y to the power of 4 times 3, that's 12, over what? 4x cubed, 4x cubed, y to the power of 15. This denominator is not being affected by this power at all. It is not affected. So what we are going to do now is to simplify that. For I have minus 2 to the power of 3 is 8 minus 8. Minus 8. So the other terms come in x to the power of 21, y to the power of 12. All over what? 4x cubed, y 15. 4x to the power of 3, y to the power of 15. So let's simplify. There are terms that we can simplify further, like x and y. You can see. So first of all, minus 8 divided by 4 is minus 2. Minus 2. Good. So x to the power of 21 divided by x cubed. I have x to the power of 21 based on the second law minus 3. They are of the same base. So I'll subtract the second power from the first. Then times y to the power of 12. 15 here, y to the power of 15 here is of the same base. Sorry, y here has the same base as this 10. So I have y to the power of 12 minus 15. So what we have next is this. Minus 2. X 21 minus 3 is what? 19. Sorry, 18. 18. Then I have y to the power of 12 minus 15 is minus 3. So this is the solution to this what? Problem. Okay, so let's talk about the fifth law. The fifth law. Actually, the simplest of all the laws of indices. It says a raised to the power of 0 is 1. So actually, we can simplify based on what I just told you right now. You can actually tell me the answers to all these questions. So question 1 says 2a over b raised to the power of 0 is 1. There are no two ways about it because everything is raised to a power of 0. Question 2. 10 to the power of 0 actually is also 1. And question 3, I'm not going to do much here. This, all the terms here, everything here, they are raised to the power of 0. So it becomes 1. And 8x times 1 is what? 8x. So the answer to number 3 is 8x. It's as simple as this. This is the law. Now to the sixth law of indices. What does it say? It says, if I have a to the power of minus x. Now, in this case, the index here, which is x here, is negative. What does the rule say? Remove this negative sign by taking the reciprocal of the 10. So I will have 1 over a to the power of x. Now, this rule, this expression can be written back to this. I told you it works forward and backward, so it's the same thing. But this is the rule. So let's solve these 5 questions on the board. And the question says, write them without negative exponent. That is, we are going to remove this negative exponent in each of the questions. So let's see how we're going to do that. Question 1. AB to the power of minus 2. So what I will do here now is A. B is what is being affected. So A is not being affected. So I will have A times the reciprocal of this will now be 1 over B squared. That's actually equal to A over B squared. I guess you know that these terms are joined by product, of course. Question 2. AB to the power of minus x. So in this case, everything here is being affected. Everything in the bracket is being affected. So I will take the simple reciprocal 1 over AB all raised to the power of 4x. This is the solution. Question 3. 2ab to the power of minus 1. 2ab. B is being affected by negative exponent, and all is being affected by a power of 2. So this B is what we are going to affect here. But the fact it's being affected, let's apply, I think, the 4th rule, or the 3rd rule. This is 2 squared, that's 2 to the power of 2. Then A to the power of 2, I guess you know what I'm doing right now. And B to the power of minus 1 times 2 is minus 2. B to the power of minus 2. So what I will do now is this. 2 to the power of 2, which is what? 4. A squared. B to the power of minus 2 will now be over B squared. So this is it. But if I can also write this as 2A, the B will now be affected over B, then all squared. I can write it as this as this or as this. It doesn't matter, depending on how the answer comes, if it is an exam condition. So the next question, that's question 4. I'm asked to write a to the power of minus 2 over b to the power of minus 3 without negative exponents. Question 4. Okay, let's see how I'm going to tackle this. This is simply equal to what? Okay, let me write this as a product. A to the power of minus 2 times 1 over b to the power of minus 3. This is what it means. This actual expression, I have expanded it in this form. So I have a to the power of minus 2 will now be written as 1 over a squared times b to the power of minus 3 will now be b cubed. Good. This entire term turns, or this entire, this term turns to b cubed. This is what it is. So I have 1 times b cubed, mind this is over 1. So 1 times b cubed is b cubed, and a squared times 1 is what? A squared. So this is what the answer is to this question 4. Then the last question, which is question 5. Write that 12a over n to the power of minus 3. Write it without negative exponent. Like what I did here, this is equal to 12a times 1 over n to the power of minus 3. And this minus 3 will disappear. N turns to a positive exponent when this becomes 12a times n cubed. So the minus 3 will disappear and the reciprocal of this will be taken. So I have this 12a times m cubed. That is actually 12a m cubed. So this is what I have. This is it. So it's actually simple. It's actually simple to understand. It's actually simple to comprehend. Indices is a very simple subject. Watch this video to the end. I have a lot for you. So let's handle the second law of indices. The one that has to do with fraction. That is the index. The power that has to do with fraction. So let's handle that part. What does the law say? If I have something like a raised to the power of x over y, what is this equal to? What does it mean? It is equal to the y root of a all to the power of what? X. That is, the term that serves as the denominator will form the root, while this numerator will be the general power. So it means that if I have 2 raised to the power of 1 over 3, this is what? The 3 here will form the root, that's the cube root of 2, all raised to the power of 1. That's what it means. So let's attack these questions. Question 1 says, simplify 2 to the power of minus 1 over 3. So before we can actually do anything, let us eliminate this negative index. So I have something like, or I have this 1 over 2 to the power of 1 over 3. I know you understand what I've just done. So we have to simplify this, and this will now be equal to what? 1 over what? This 3 here will form the root, that's the cube root of 2. All raised to the power of 1. You know it is the cube root of 2. So this is the answer. So the question 2 says, simplify 4 to the power of minus 3 over what? 5. Of course, you know that we have to eliminate this negative index first, so that we have a positive 1. That is 1 over 4 raised to the power of what? 3 over 5. So this will now be what? 1 over the 5th root. The 5 here as the denominator will form the type of root, and the 4 all raised to the power of what? 3. So this is what it is. Question 3. Let's approach question 3. Now 16, the square root of what? 16x to the power of 4, y to the power of 4, 6. It's simple. When we talk about square root, we're talking about number 2, cube root number 3, fourth root number 4, and it goes that way. So because of this now, the square root of 16 is what? 4. Now, this is x to the power of 4. This 4 here, a very simple way to solve this. This 4 here as a power, we divide this 2, serving as the square root now. That 2, so I have x to the power of 2. The same vein, 6 here, we divide 2, I have y to the power of 3. And you know that square root is either positive or what? Negative. Don't forget. Question 4. The cube root of what? 27x to the power of 9, p to the power of 6, q to the power of 3. A very simple way to solve this also. Cube root of 27 is 3. Now, x is carrying the power of 9, and 9 is divisible by 3. So 9 divided by 3, I have 3. X to the power of 3. P to the power of 6 divided by 3, I have 2. Then Q, 3 divided by 3, I have what? 1. That's 3x cubed, p squared q. So this is the solution. There is no plus or minus. Cube root does not carry plus or minus. That's the nature of the type of root. So we have actually treated the 7th laws of indices. Wow. So we have done something right now. So I'm taking you now to exponential equation, initial equation, how to solve initial equations. Stick with me as we move further to exponential equation. Let's go.